If I fell into this frozen lake, my chances of survival would be counted in minutes. But this very same lake, under all the snow and ice, the snapping turtle could last a whole winter. While temperatures drop, these animals don't try to stay warm. Instead, their metabolism slows directly, sometimes even more than 90%. They don't fully sleep and they don't stay active. They enter a state of extreme energy conservation. That state is brumation.
All kinds of creatures brumate. Frogs, snakes, alligators, turtles. But today I want to specifically talk about turtles. Now, why do they brumate? Well, unlike birds who migrate, turtles don't have wings. Sorry. Turtles are also cold-blooded, meaning they get heat from external sources like the sun, unlike warm-blooded mammals that can pack on body fat and hibernate.
Brumation is a winter strategy used by cold-blooded animals, also known as ectotherms.
In addition to being cute, turtles are classic examples of ectotherms. They regulate their internal body temperature by basking in the sun to absorb heat, since their metabolism alone cannot maintain a constantly high body temperature. But when days shorten and temperatures drop, they prepare to brumate. After taking its last breath of fresh air, a turtle won't use their lungs to breathe again for months. Instead, turtles rely on gas exchange through their cloaca, commonly known as butt breathing. With very little oxygen and no food, winter becomes an extreme metabolic stress test. But a turtle has a secret weapon, its liver. The liver stores glycogen and fat for energy. It also produces an enzyme, lactate dehydrogenase, or LDH for short, that enables the anaerobic production of ATP through glycolysis. This gives the cells just enough energy to stay alive. Equally amazing is how the turtle's shell helps during brumation. Prolonged anoxia causes toxic lactic acid to build up, but it is buffered and neutralized by the calcium and magnesium carbonates in the turtle's shell and bone. During brumation, the turtle's metabolism is suppressed through this coordinated biochemistry, as well as epigenetic control. One important mechanism involves histone methylation. By modifying histones, the term for the protein that packages DNA into chromatin, the turtle selectively upregulates genes essential for stress resistance and survival, while repressing many energy-expensive, non-essential processes. In other words, the genes needed for stress resistance stay on, everything else powers down. Brumation lets the turtle conserve energy, protect its cells, and survive months without food and little oxygen. Then restart metabolism when spring starts. Brumation isn't just slowing down. It's actively reprogramming gene expression to survive. So when you see a turtle trapped under the ice, it's doing just fine, and whatever you do, don't break the ice.